Okay, welcome back. Today we're going to talk about significant figures and how to round. So remember that precision is how close how close our measurements are to each other. Not necessarily how close are they to being right, but how close are they to each other. And precision is often limited by the tools available. So what precision is limited by is the number of tick marks on what you're using to measure. So what we do is we say the number of significant figures is all the known digits plus one estimated digit. So if you look at this ruler right here, I know that this piece of pipe is between the 5 and the 6 centimeter mark. That is a known digit. That is after the 5. Another known digit is it is after the 0.2 centimeter mark. It is between that 0.2 and that 0.3. So I can confidently say it's 5.2 centimeters long. But I'm going to have to estimate one digit past what I know is there. So if you look at a ruler, or if you look at a beaker, and the beaker has markings of 0, 100, 200, 300, 400. I know if the water is between 100 and 200 milliliters. I can estimate it's 120 or 130. But if it doesn't have enough tick marks, I can't estimate 131. I can't estimate 147. I can only say 130 or 140. Right here, we would say this measurement of 5.23 centimeters. I know 5, I know 2, I know 3. That it has 3 significant figures. That's not saying that's how many digits are there, that's how many of those are significant. So what is a significant figure? It's all the known digits plus one estimated digit. But there are 5 rules that govern significant figures. The first one is non-zero numbers are always significant. So 5.23, there are 3 significant figures there. We're not talking about the actual digits, we're just talking about how many of them are significant. Rule 2, zeros between non-zero numbers are always significant. So that means if I had 504, there are 3 significant figures in that number. Okay, that 0 in the middle is significant because it's sandwiched. Rule 3, all final zeros to the right of the decimal are significant if they are after non-zero digits. So, if it were 5.20, there are 3 significant figures there. Because this is, even though it's not sandwiched, it's after a non-zero digit, after a decimal. Rule 4, placeholder zeros are not significant. If I'm going to remove it when I write it in scientific notation, it is not significant. So if I had 0.01, there is actually only 1 significant figure there. And then if I have a counted number or a defined constant, that's going to have an infinite number of significant figures. And rule 6, if you've got a line over a number, that makes it and everything before it significant. So, if your head is thoroughly confused now, don't worry, we're going to go through many examples and look at those. So, we're going to think about each of our rules. We're always going to go through rules 1, 2, 3, and 4 in that order and apply it. So, how many significant digits or how many significant figures? So, I'm going to look at 9,406. So right here, we know the 9, the 4, and the 6 are all significant because of Rule 1. They are all non-zero digits. That 0 in the middle is sandwiched, so that makes it significant. So my answer right here is that there are 4 significant figures. Let's look at our next example. On our next example, the number that we're given mathematically is 0.002405. So, what do I know is significant? The 2, the 4, and the 5, because they are non-zero digits. So that's Rule 1. Rule 2, sandwich zeros are significant, so that makes the 0 between the 4 and the 5 significant. Rule 3, zeros after decimal. Okay, we've got some of those. After a non-zero digit, we do not. These two zeros right here, that are between the decimal and the 2, are not after a non-zero digit. Rule 4, they are placeholder zeros, so they are not significant right there. So that means that there are 4 significant figures right there. Let's look at our next example, 1.0024. Well, I know the 1, the 2, and the 4 are significant due to Rule 1. And then those 2 zeros, they're between the 1 and the 2. And since they are both between there, they are sandwiched. So that means that this has 5 significant figures. Alright, next example, 1.0500. The 1 and the 5 are significant according to Rule 1. The sandwich 0 is significant according to Rule 2. And then Rule 3, zeros after a decimal, after a non-zero digit are significant. So these 3 are all after that 5, and they are all after a non-zero digit. So that means all 6 of those numbers are significant. Alright, 0.0584. We know the 5, the 8, and the 4 are significant. There's no sandwich 0, so Rule 2 does not apply. And Rule 3 does not apply, because even though that 0 is after a decimal, it's not after a non-zero digit. And Rule 4 does apply. These are placeholder zeros. They're not after another non-zero digit. So there are only 3 significant figures here. Next example, 1,000. That 1 is significant. There's nothing to sandwich those zeros, and there is no decimal. So there is 1 significant figure there. But then I have 1,000.000. And right there, I've got 1 significant figure. I've got a decimal, and I've got 6 zeros in here. And the reason they are all significant is because there is a decimal, and it is after a non-zero digit. So that decimal acts as another non-zero digit, sandwiches these 3, okay? And then, because of Rule 3, these 3 trailing zeros are after a non-zero digit, even if they're 3 digits away after a decimal. So right here, there are 7 significant figures. The thing to remember here is we're not talking mathematically. What we're talking about is how precise is the measurement. So this one right here is not as precise as this measurement on the end. What that tells me is the scientific instrument I was using for that first measurement is not nearly as precise as the one as I was using for that last measurement. Significant digits tell me how precise the scientific instrument is. So let's look at these right here. I want you to pause it, I want you to go through, and I want you to see if you can decide how many significant digits each of these have. If you have scientific notation, you ignore the times 10 raised to the second. So pause it, come back and see how many there are. Hopefully your answers line up with mine, and hopefully you got those right. Right here we've got 5 dogs, and we've got 12 inches in a foot. Remember Rule 5, if it's counted or if it's a definition, it's going to have an infinite number of significant figures. What that just tells me is that I can be extremely precise when I'm counting, and when I'm measuring, because it has an infinite number of significant figures, it should be right all the time. I should be extremely precise. So now let's talk about rounding significant figures. Remember your rounding rules from math. If the digit to the right is less than 5, you don't change that last significant figure. Rule 2, if the digit to the right is 5 or higher, you round up. So, when I round for exam exemptions, if you have a 94.5, I typically round up. If you have a 94.4, I round down to a 94. So if you have a 94.5, I round up to a 95, and you are exempt in the spring, not in the fall. So let's look at this right here. And we're going to have to use our significant figures knowledge and our rounding knowledge. So right here it says, I've got the number 1.4584. It has 5 significant figures in it right now. And I'm going to do some rounding. So where it says round to the following, so I'm going to round to 4 significant figures. So my 4th significant figure is the 8. So when I'm rounding to 4 significant figures, I'm talking about the 8 being my last number. So I'm going to write 1.4584 all out. I want to round to the 8, so I have to look at that 4. What does that 4 do to the 8? It does not change it because it's less than 5. So my answer would be 1.458. If I were to round this to 3 significant figures, I would take 1.4584. I would go to my 3rd significant figure, 145. The 5th is my 3rd significant figure. I would look at that 8. How does it change that 5? Well, it's bigger than 5, so it's going to make it round up. So when I round to 3 significant figures, it would be 1.46. If I'm rounding this to 2 significant figures, I'm going to take the 1.4584. I'm going to look at my 2nd significant figure, which is that 4. I'm going to look at that 5. How does it affect it? It would make it round up, so this will become 1.5. And if I were rounding this to 1 significant figure, 1.4584, that first significant figure is 1, so I look at that 4, and it would not cause it to round up, so my answer would be 1 right there. So if you look at the difference right here, what significant figures do is they allow me to be more precise. 1.458 is a much more precise measurement than just 1. So let's practice rounding again. 2,486. So if I were going to round that to 4 significant figures, it would be 2,486. Now, if I were going to round it to 3 significant figures, 2,486, I'm going to look at that 8 because it's the 3rd significant figure and see what that 6 does. So the 6 would make it round up, so it would be 2490. Why did I have to put that final 0 there? Well, on the previous example, we kept dropping numbers because it was after a decimal. Here, if I dropped that number, it would, instead of being 2,486, it would just be 249. Don't change your place values. It's okay to change your numbers when you're rounding things, but make sure you keep things in the right place value. If I'm going to round this to 2 significant figures, 2,486, the 2nd significant figure is that 4. That 8 is going to make it round up, so that would become 2,500. Make sure that if you're dropping those, that you replace them if it would change the place value. And then to 1 significant figure, if I've got 2,486, that 2 is what I'm looking at. The 4 is not going to cause it to round up, so it would be 2,000. So that is how we round when we are taking into account significant figures. Thanks for your attention.